Now it's time to turn to a router's specialty, which is WAN connections. Routers are the only thing that can get us connected to the wide area network. So what I plan on doing in this video is walking through the categories of WAN connections. Because when you go out into the world and start setting up networks, you have to know which kind to buy. Second thing we'll talk about is the layer 2 WAN protocols. Layer 2, we've talked about it so far as Ethernet. That's where our MAC addresses come from and so on. The WAN is not an Ethernet world. The WAN is totally different. So we'll look at some of the different protocols that run over the WAN, and then we'll configure two of the most common, HDLC and PPP. Wide area network connections come in many different shapes and sizes, depending on what you as an organization are looking for. Now, first off, the WAN links are what provide your connections between your offices, which could be within the same city, or they could be miles apart, thousands of miles apart around the world. That's where our WAN connectivity comes in. Now, the first thing that it does is define a new layer 1 and layer 2 connection type. You can see our OSI model has walked onto the set again. And down at the bottom, you can see physical and data link layer. And we've moved away from our physical connections being like Ethernet cable, Cat5, and RJ45 connectors. And we've moved over to serial physical connections. That's the language or the connector type of the WAN. Now you move up a data link layer and there's no more MAC addresses. The MAC addresses are an Ethernet thing. We've moved into things like frame relay, ATM, PPP, HDLC, and this list goes on. I'm just thinking MPLS, Metro Ethernet, ISDN, and there's just this whole spattering of wide area network technologies that you can use, each one having its own different data link layer language that it speaks. For instance, frame relay. Looking at this guy right here, that's not only a connection type, meaning you can call up a service provider and say, I would like a frame relay connection, but it's a layer 2 protocol as well. It has its own address known as a DELC. It's the same thing as a MAC address, but it's called a DELC, Data Link Connection Identifier. And that's how endpoints communicate in a frame relay cloud, connecting over the wide area network. So really, when you're choosing between the many different types of WAN connections, this and speed are going to be your major determining factors. Speed being how fast does it go, and the price being how much are you willing to pay per month. Just to give you an idea, I was actually, one of the WAN connections, not on the screen, but I mentioned, is called Metro Ethernet. It's one of the latest and greatest ones out there where they use fiber optic cables to do a WAN connection. And I was reading about it in the magazine, Network World, and they did a price test, to try and find who would be the cheapest Metro Ethernet. The benefit of Metro Ethernet is speed. You get tons of it, as in thousands of megabits per second. But so I'm reading this article and I'm like, oh, this looks good, looks good, looks good. Because I actually have one of my clients in mind for this connection types. And I flipped to the last page and they say, and all of this at a mere $142,000 a month. That's the kind of prices that you're looking at when you get into Metro Ethernet. And for a huge corporation, $142,000 a month might not be that much money. I'm just like as I try and get that out. That's the kind of differences they are. And you could move all the way down to a connection that runs $20 or $40 a month, but sacrificing a whole lot of speed. With all those different kinds of WAN connections out there, let me boil it down to the three major categories: leased lines or dedicated circuits, circuit switched, and packet switched. Now, lease lines are the most common types you'll hear about when you hear somebody say, oh, I have a T1 line or I have an E1 line. They're usually talking about a leased line connection. Although, technically, there's no such thing as a T1 line. When next time somebody says, hey, I have a T1 line, I dare you, ask them, what kind of T1 line do you have? They'll probably just look at you going, I have a T1 line. T1 is actually just a measure of speed. When somebody says I have a T1 line, T1 equals 1.544 megabits per second. I could have a T1 cable modem connection, or I could have a T1 DSL line, or a T1 frame relay, or I'm fill in the blank, any kinds of connections. T1 is just a measure of speed. So when you hear somebody say I have a T1 line, they're usually talking about a T1 CAS connection, which is essentially dedicated bandwidth between your locations. That's most of the time when you see a network diagram. I think you've even seen one in here plenty of times, where you see router 1, router 2, and there's a zigzag between them. That's usually a lease line connection. The benefit of this is it's dedicated bandwidth. The bandwidth is yours. If you buy a T1 CAS connection, that means that bandwidth is sitting there all the time for you. If you're not using it, no one else is. Great thing about lease lines is they're always there, always on, very reliable. Bad thing is this. They are the most expensive of them all. So you have to factor in the cost on that. Circuit switched is on-demand bandwidth between your locations. Circuit switch is anytime you hear a you know, and all the noise that happens, it's the modem. That's why it says on-demand bandwidth, meaning when you need it, you are going to dial up to get it. The benefit of circuit switch is that they are great on price, meaning you can get, you know, a dial-up modem connection between offices for 20 bucks, 40 bucks a month plus taxes and that sort of thing. So very, very low cost and available just about anywhere you go in the world. The disadvantage of them is number one, the setup time, at least for the modem side of thing, and bandwidth. It's using the telephone company, which was never designed really to handle the high-speed bandwidth needs that we have nowadays. That's why DSL, which is a telephone or telco technology, is causing the telephone company to rip up streets everywhere and install fiber optic cables, because the old cables just weren't designed to handle the distance and the reach and the bandwidth of modern times. So I would say circuit switch is the cheapest, but least amount of bandwidth. Now the last one down there is packet switched. That one is the current darling of the industry. It's considered shared but guaranteed bandwidth between locations. Usually when you're talking about a packet switch connection, you'll see a cloud in the picture, and you'll see some routers kind of dangling off that cloud, something like that. You know, maybe offices up here, maybe that's Arizona, Texas, and so on. So with this kind of connection, everybody kind of taps into a shared bandwidth cloud where the service provider has all this bandwidth. Now, the price that you pay the service provider determines what your guaranteed bandwidth is. You might get a little more than your guarantee. It's known as bursting, but they'll give you at least what you're paying for or what you are considered guaranteed. The great thing about these kinds of connections is I could have one serial interface, one serial port that connects to the cloud and connects to multiple offices through this concept known as virtual circuits. Just a simple concept that you call up the service provider and say, hey, I want to use frame relay and I want to connect to Texas and Florida. And they'll say, okay, well, here's the price for each one of those connections. You say, great. And they'll set up a virtual circuit through their cloud that your router can go through to get to those offices. So it's very flexible. So with one serial port, I can connect to potentially 100 different offices if that's what my design was really set up for. So you can see frame relay is one type, ATM is another type. There's an older one known as X25, which is common overseas, but very, very flexible connections and very reasonable on cost. That's why they are currently the rave of the industry. Now, if you haven't been in a business that has a WAN connection before or seen one of these, it can get really mind-boggling as to the physical look of this. How does this look? Well, I wanted to diagram this out for you so you can see how a WAN connection looks from the office perspective. Right up here in the upper left is your router. In this case, I have a Cisco 2600 series router that I'm using in that picture. Now that router, you know, if we were logically diagramming it, would have an Ethernet connection. This is actually right here. It's the Ethernet port. That would tie up here to the switch, and the rest of your network, all your PCs and stuff like that, would connect over there. So all the PCs and whatnot would come to this router and be looking for the WAN port to get off of the network. Now, we can buy nowadays two different types, well, actually even more than that, but two major types of WAN cards that we can slide right into, you can see this slot right here. That is considered a WIC slot, a WAN interface card. So this is known, this little widget right here is known as a WIC ccent28-1T, meaning it's a single serial port connection. Those have been around for eons. Before the age of dinosaurs and whatnot, those were around. And they still are out there a lot of places. Those kind of connections give you one serial port per card, and you would buy one of these cables. Typically from Cisco, it's about, well, if you buy it from Cisco, about $100. If you buy it off eBay, about 10. This is the end of the cable that would connect to your serial port that plugs into your router. This wacky looking connector moves over here to this device, which is known as a CSU DSU. Now that does a lot of things, but that really is just an expensive modem if you really break it down. It's the CSU DSU, and what it does is converts. This is the service provider's wall jack that they'll install when you come pay them money. They actually call this the point of demarc. I'll get back to the CSU DSU in just a moment. Demarc, ARC. That's a way to abbreviate. It's a demarcation point. And that is where the line of responsibility passes. Meaning if something on that side of the connection breaks, the service provider should pay for it because it's outside of your premises. If something on this side of the connection breaks, that means you pay for it because that is on your side of the premises. That's the line of demarc. I sometimes feel like I should teach this in the real world way, which means if something on that side breaks, the service provider convinces you that it's on this side, and then you pay for it anyway. But that's you know, another side of the story. So we have this cable in the wall that the service provider installs, and we just connect that using a typical cable connection, RJ45, or it's known as RJ48 for a T1, and that will plug into the back of our CSU DSU. This CSU DSU will convert this cable type to something else, and that is what this cable connects to. There's actually many different kinds of these connectors that you can get that connect to the CSU DSU. There's about 5 of them actually that are out there that are standards, and you just buy the right one. Like this, I know it's kind of hard to see, but that's considered a V.35 connection, and this CSU DSU has the female port, and you plug from the CSU DSU into your WAN card. Did you follow that? I know I kind of jumped around. Let me just hit the high points. Wall jack, cable, CSU DSU, converts to a serial cable, which plugs into your WIC 1T. Now, with that in mind, this is known as a WIC 2T. It's one of the newer cards. Not brand new, but it's been out for it's fairly new, within the last 5 years or so. This gives you 2 serial ports per card. That's awesome. And it uses, this is known as a smart connector. It's kind of a thin little connector that you need. You just have to buy a different cable for. Typically a little more pricey than the WIC 1T, but 2 for the price of 1. That's how I look at it. So those are the 2 kinds of cards that will be considered serial ports, and you would connect with a serial cable. The only other card that I'd like to talk about here is this one. You'll typically see this as a T1 card. That's how they'll typically be labeled. I think the official part number is WIC 1T DSU. Don't quote me on that, but I believe that's what it is. The beauty of this is with technology advancing, they've been able to take all the functions of this little box and put them into that card. If you look really close, you won't be able to see it right now, but if you actually get one of these cards and look, it actually says on that little blue writing, T1 CSU DSU. It has a built-in CSU DSU on the card. So the cool thing about these cards is that you can slide them right in that port and then connect the cable straight to the wall jack without the need for all this converter and serial ports and all that. It does all of it for you. So that's pretty great. They also sell these in 2-port models where you can get 2 ports per card, but they're a little bit more expensive. So that's the physical layout. I kind of just took a step back from the screen and looked at it. I'm like, wow, that is a lot of stuff. But hopefully you're able to piece together physically how the router connects to the WAN. With that foundation in place, I'd like to move into what I would think would be the easiest part of this whole thing, configuring the lease line connections. At this level, the ccent level, Cisco only expects that you are able to configure a dedicated or lease line connection between 2 points, like, you know, using some of the terminology I just used, a T1 line between offices, which We have router 2 and router 3 directly connected together. Now, all along, we've been using this network diagram in our video series to set up NAT, to set up routing, all of that, and we've just kind of assumed this WAN connection has been there. But that's because I configured it beforehand. Now we're going to take a look at how I did that and do it ourselves. I'm going to take us to router 2, which is this guy right here. Just get familiar. It's got the IP address 192.168.2.1 on its serial interface connected over to router 3. So I'm going to do my favorite command, show IP interface brief, and I can see there is my serial port that is plugged into my router. I have one of those WIC1T interfaces plugged in there. There's the IP address. Physically it's up, and data link layer is up. So that's the serial interface that I'm using. I'm going to type in another command, show interface serial 0/1/0 to focus in on that. Now I can see the hardware is serial, IP address is right there, maximum transmission unit is 1500 bytes, that's how big our packets are, and so on. Down here is what I want you to see. Encapsulation HDLC. What that is, HDLC, is the layer 2 protocol that it's running between router 2 and router 3. That's the replacement for Ethernet. Now, HDLC stands for high level. It's actually high dash level. That's why it's not HLDLC. High level data link control. This protocol, the way Cisco runs it, is a Cisco proprietary protocol, meaning that router 3 better be a Cisco router or else it's not going to be able to speak this same language that our serial port is using, and we'll have to use something else. The benefits of HDLC is its simplicity. It is very simple to set up a router using HDLC. You just plug cables together, meaning I just plug the cable in and make sure both sides are running it, and it just works. There's no real configuration necessary special to the serial port to make this happen. It just starts working. It's very fast. The alternative to HDLC is called PPP. Perhaps you've heard of it before. PPP is the alternate layer 2 protocol. I kind of refer to it as the planet's most popular protocol, but really it stands for the point-to-point protocol. It is an industry standard layer 2 protocol that I can use if these routers, one of them is not a Cisco router. So say this was a Juniper router down here. Well, I could go in there and use PPP on its end of the connection, and Cisco can do the same thing. So let me show you first off, how to configure the routers for PPP. Now, I only have a telnet connection to router 2, just to give you an idea. I'm sitting on this PC right here, telnetted to router 2. I don't have a console cable to router 3. It's actually in the other room, which is very far away, simulating a WAN link between our two offices. Now, my point in telling you this is I don't want to have to walk to the other room and plug into the console port and goof things up. So let me show you what I'm going to do. I'm going to go and telnet to router 3. I'll look at the IP address first. The IP address is 192.168.2.2. That's this guy right here. So I'll type in telnet 192.168.2.2. There we go. Password. I'm in. Router 3, privilege mode, in. Great. So I'm now logged into router 3. I'll do a show IP interface brief on its end, and I can see that the serial 0/0 is the port that I'm using. That's module 0, port 0 to connect over the WAN, and there's my IP address. I'll do a show interface serial 0/0, and I can see the encapsulation on this end as well is HDLC. So I'm going to go into global configuration mode. This is how we use and change it to PPP. I'll type in interface serial 0/0, and I'll type encapsulation, do a question mark. You can see all the different WAN kinds that we have. There's our ATM, frame relay, HDLC, and right there is PPP. So I'll put encapsulation PPP right on there and hit enter. Do you see what just happened? My prompt never came back. That's because I just took down the WAN link between router 2 and router 3. The WAN link is now disabled between them because this guy is speaking PPP, this guy is speaking HDLC. It's not the same language. Now the problem is I was telnetted over there. Now, I haven't talked about all the nifty telnet commands, but there's one I can use. It's actually Control-Shift-6X to suspend the telnet session and hop back over to my router because my telnet session is dead. Now, let me show you. I'm going to do a show IP interface brief. Look at what happened here. On router 2, it still has a serial interface, still has the IP address. Physically, it's still there. It still has a cable connected, and it's getting clocking from the other side. But the line protocol, or the data link layer, is down. What a great example that you can see, what that output looks like when it's up physically and down with the protocol. That usually means you have an encapsulation mismatch. So I'm going to fix it on this end. I'll do interface serial 0/1/0. Enter. I'll type in encapsulation PPP. Enter. I'm going to go back here and type in terminal monitor, which will allow me to see the status messages as they come through. Look at that. The line protocol just came back up. It says line protocol changed to up. If I do a show IP interface brief, there it is. And you can see right here, I'm resuming my telnet session. My telnet session came back alive because the router 3 link now came back online. They're both running PPP. So I'm on router 3. You can see I'm kind of telnetting back and forth. I'm going to do a show interface serial 0/0. And now I can see underneath here, I'm running PPP. Notice it says LCP open, open IP, CP, CDP, CP, and so on. Those are actually known as control protocols. That's what allows TCP IP to work over my WAN link. And another protocol known as CDP. We'll talk about that in the next video, working over my WAN link. Cool. That's all there is to configuring lease line connections, is going underneath that interface and typing in encapsulation. Now, there is one more thing that I want to show you, and that is how to work this in a lab environment. I realize some of you may be buying routers in your home to set this up and practice this on some live equipment. What you have in that world is something known as a serial crossover cable. As a matter of fact, I'm going to pause the video and just show you a picture of one real quick. All right, here we go. We've got my Google Images search fruitful yet again. This is known as a serial crossover cable. Each one of those ends of that cable plugs into a serial interface, one of those WIC1T ports on our routers. So in a lab environment, you can get one of these. You can just get those off of eBay and connect your routers together, and it simulates as if there was a service provider in between. But what I want to point out to you is actually what's labeled on those ends right there. It says DTE and DCE. You guys see that? Let me jump back here. When we're looking at our serial interfaces, let me just draw the physical look again. You got your wall jack, right? Run the cable to the CSU DSU. That goes up to your router with a serial cable, and your router connects to the local area network. Now, when you're connecting and you're buying a cable right here, that serial cable to go between the CSU, DSU, and your router, you actually will buy a cable that one end is known as the DCE, and the other end is known as the DTE. Stands for Data Terminal Equipment. And this one, actually, the best way to remember it is think that the C stands for clocking, because the service provider sets the clocking for your WAN connection. That says how fast your WAN connection goes. It works kind of like, have you ever played the piano before? Like one of the piano metronomes that go back and forth. They're like tick, tick, tick. They keep your timing. And in a CSU DSU, it's actually saying send, 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 send to your router so it knows what speed to send at. Now you pay the service provider more money and they'll program the CSU DSU to say send, 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 and they'll be able to send at a faster rate. Now in a lab environment, when we are connecting two routers back to back, we don't have a service provider in between. We have this cable that simulates the service provider, but one end, you can see right here, is considered the DCE. So let me let me speak the truth. The truth about my connection here is I don't have a real service provider between my routers. I don't want to pay $124,000 a month to have a connection between my routers. It's not that much, but so I have to have a crossover cable setting the clocking. I'm going to type in the command, and by the way, I'm saying this to set up your own home labs, but I don't want to mislead you. If you are studying for the exam, this is a potential exam topic as well. I'm going to type in show controllers serial 0/0 on my router 3. And I want you to see here, right up here, it says, aha, the DTE end of the connection is plugged into this one. It's able to tell what end of the cable is connected, and I see clocks detected, meaning somebody is setting the clocking. And that says to me, in my mind, oh, router 2 must have the DCE end. So let me kill my telnet session. I'll do a show controllers, and I'll do serial, I think it was 010 on this one. Yes, it is. Look at this. The cable is DCE, and the clock rate is this. That's what I've actually set up under my interface. So in order to get this connection working between router 2 and router 3, I did have to go under my serial 0/1/0 port and type in clock rate. I'll do a space question mark. This sets the speed of your connection. You can see speed in bits per second. So if I were to type in 5600, that'd be like a 56 kilobit per second modem. Remember, this is bits per second. We think in kilobits per second. Moving down here, right around there is about a T1 speed, 1.544 megabits per second, or this is technically the exact accurate speed from the command line, but that's all in bits per second, which is much less than megabits or kilobits per second. So if you are in a lab environment, you want to make sure that you connect the DCE side to the end of the router that you plan on setting the clocking for. If you do not set the clocking in a lab environment, the connection won't come online. In the real world, the service router will set the clocking for you. That is the world of WAN connectivity. It's pretty cool stuff when you get into it. And I know right now we just kind of saw the basic overview of what WAN connections look like and the categories. But if you jump into the part 2 of this series, that's where we get into things like frame relay and frame relay. I'm just trying to think of some other WAN connections. Frame relay is a really cool technology. So that's discussed much more in the part 2 of this series. But for now, we walk through the categories of WAN connections, which was the circuit switched, packet switched, and lease line styles. Those are the 3 major categories, but they are really a replacement for the layer 1 and layer 2 of our OSI model. They replace Ethernet. They are what allow us to connect around the world. We looked at the layer 2 WAN protocols. The 2 that we discussed and configured in here was HDLC, the high-level data link control, and PPP, the point-to-point protocol. But there are many others out there, as we've seen: ATM, frame relay, MPLS, and so on. Finally, we looked at HDLC and PPP WAN connections and configured them and verified that they were running by using the show interface commands and seeing what happens when we have a mismatch between those. All of that goes into configuring those WAN connections. So I hope this has been informative for you, and I'd like to thank you for viewing.